Hello everybody, welcome to this recording of your Redox reactions. Before we even move or start answering the question, I would just like us to have a quick reminder of what the Redox processes entail. The first process that you need to be able to define is the process of oxidation. Well, with your oxidation process, what is it that we know? We know that oxidation is a process that occurs when there is an increase in the oxidation number of the species. In oxidation number of the particular substance or species. And this increase in oxidation number will occur because the substance in particular is going to lose electrons. So it happens with the loss of electrons. And when that happens, the substance that is undergoing a process of oxidation is referred to as the reducing agent, because what it does is it causes the other species to be reduced, and when the other species has been reduced, the particular substance that has caused that subsequently undergoes a process of oxidation itself. So it causes the other species to be reduced, and then it suffers a process of it causes the other one to be reduced, and then it will undergo the process of oxidation. So now remember the processes of oxidation and reduction occur simultaneously, but they are opposite. So when it comes to the definitions of the process of reduction, you just have to look at the definition of what you've written about oxidation, and for the reduction it's going to be the opposite. So when we look at reduction, what are we going to say? Well, reduction is a decrease in oxidation number, in the oxidation number of the species. So reduction is a decrease in the oxidation number of the species, and oxidation, I just need to add that there, oxidation number, and then it happens through the gain of electrons. So the species that gains electrons and becomes reduced would have caused the oxidation of the other. So this is referred to as the oxidizing agent. So your oxidizing agent undergoes reduction, because when it causes the other to be oxidized, it suffers the opposite process of becoming reduced. All right, so now we can now look at these questions and start answering them. Number one says, define the term oxidation with reference to oxidation numbers. Well, as we've just mentioned above, that the process of reduction of oxidation is one in which there's an increase in the oxidation number. There's an increase in the oxidation number of the substance. And then calculate the oxidation number of chromium in dichromate. So when you look at it, you just look at the formula and you look at all the substances present, and it's also important that you look at the net charge of the species. In this particular case, the net charge of the species is -2. So we are asked to calculate the oxidation number of chromium in chromium 2+. So what you then look for is the oxidation number of chromium 2+, which we don't know. So you'd say 2x plus 7 times -2, which is the charge of the oxygen, is equal to the net charge of the species, which is -2. So 2x minus 14 is equal to -2. Transpose the 14 and then you're going to have 2x is equal to plus 12, and then divide both sides by 2 to calculate the value of x, and you're going to get the answer being plus 6. So the oxidation number of chromium in dichromate is equal to plus 6. And then you're asked to calculate the oxidation number of oxygen in H2O2. When you calculate the oxidation number of oxygen in H2O2, the process is the same as you used when you were calculating for the chromium. So what you would then do is you would just simply say, okay, fine, there's the formula of the substance that I'm looking for. I want the oxygen, but now I've got two hydrogens and each one is carrying a charge of plus 1, plus 2 of oxygen that I don't know, and the net charge of that is equal to 0. So from there I solve for x. When I solve for x, I'll transpose the 2 to the other side. It becomes negative 2. So it becomes 2x is equal to minus 2. Divide both sides by 2. And you are left with x being equal to minus 1. So in H2O2, the oxidation number of the oxygen is equal to minus 1. Consider the unbalanced equation below. Fe2 plus chlorine to give you your Fe3 plus the chloride ion. So when you look at the equation of the substances that are reacting, we can actually have a look. We can conclude as to what is happening, and even before answering the questions. Well, you see that the oxygen, the iron 2, the iron has got an oxidation number of 2 plus, and then it becomes iron 3. So what we can say about that is that this is undergoing a process of oxidation. So that we can therefore, if it's undergoing a process of oxidation, it's going to lose an electron, and therefore this must be the reducing agent. We can pick that up. And the chlorine is undergoing a different process. It has to be opposite to that. So what was the oxidation number of chlorine? It was 0, and then it becomes minus 1. So what it is undergoing is a process of reduction. If it is undergoing a process of reduction, that means this is the oxidizing agent. Now let us look at the questions that are being asked. From the above equation, write down the formula. They want the formula of the reducing agent. So when they ask you for the formula, they're not asking you for the name, they're asking you for the formula as is given in the equation. So the reducing agent is given as Fe2 plus. And then the formula for the oxidizing agent is your chlorine, which is a gas, and then the reduction half equation. So I'll just write here reduction, which is the one that undergoes reduction. Well, it is your chlorine. So it starts as chlorine, and then it gains some electrons, and then it becomes your chloride. But when you look at it, the number of chlorines that you have, you've got 2 of them, and here you've got 1 chloride, so you need to have 2 chlorides. Each chlorine gains an electron, and because it gains an electron, you need 2 of them. And the half equation for the process of the oxidation. So we look for the process of the oxidation process. Who was oxidized? The iron 2 was oxidized to iron 3. So the oxidation process, you write it down and you state what process it is. Oxidation. What was oxidized? Iron 2 was oxidized to become iron 3. And then how did that happen? Through the loss of an electron. But now the electrons that are lost by the iron 2 are the same electrons that need to be gained by the chlorine to give you the chloride. So what happens? This required 2 and this was giving only 1. So what you would do is you'd multiply this by 2 to balance it, and then you would have 2Fe2 plus to give you 2Fe3 plus 2 electrons, right? So now the number of electrons balance, and therefore it becomes plausible for you to balance that equation that way. So in order for you to balance it, so what you then do, or to write the net equation, is to add the reactants of the reduction to the reactants of the oxidation process, and you would write that as follows. So the net equation, write it as shown. So you'll have your chlorine plus 2 electrons plus your 2Fe2 plus, and then what products we get? You get your 2 chlorides, so you're just taking those, plus the 2Fe3 plus 2 electrons. So those electrons would then add each other out, and then you will be left with your chlorine plus 2 iron 2 and 2 chlorides plus 2 Fe3 plus. That's said and done. That is the answer to the question that they were asking. Remember the definitions and apply them consistently, and you should be good. Thank you very much for watching.